So I thought I would show you the injection molding machine that I've made. You have to excuse the handheld video and also excuse the super wide field of view because it's very tight on space here. This is in fact the kitchen in my apartment, so hence the lack of space. Yeah, so I'm filming this on my GoPro, so I can't really see what I'm showing you. The preview function doesn't seem to work on my phone, so alright, we'll see how this goes. Anyway, this here is the actual machine. You have an actuator, air cylinder on the bottom. That one is used for clamping the mold up against the hot end or the nozzle. This one right here. This is a band heater, a single phase 300 watt unit. And here you can see the very small conical shape nozzle end, or whatever you want to call it. This is the second hot end or nozzle that I made. The first one was not working well. It was overheating. Well, the whole thing was one massive aluminum piece, so it was way too hot at the top end. This is where you want the heat. You don't want the heat where you put in the plastic and where plastic pellets are subject to deterioration due to the fact that they get well, they stay here for a while, sometimes between cavities on the mold, etc. So heat is your enemy. The plastic will deteriorate. So keep this end as cool as possible. There are definitely ways I could improve this, but it seems to work for now anyway. Then on top here there's the other actuator or air cylinder. That one is probably, you guessed it probably already, but it's used to plunge this piston that I made also. This is a two-piece one. So this end you can exchange that for another piece, but this is just mild steel or something rather. But yeah, it plunges down into here. You align this one using these two fasteners or bolts, screws. Yeah, there's a plastic spacer back here to position this one at the center line. So yeah, over here is the different pressure regulators for the different air cylinders, because maybe you want to have one at a higher pressure or lower pressure clamping force. You might want that a bit lower than, or vice versa. So yeah, air comes up here from the compressor, goes into the first filter pressure regulator combo through a second filter. This is a 0.1 micron filter. This is a 40 micron filter. So yeah, and then it passes through this to each of these individual pressure regulators. So if you use normal or more regular pressure regulators, you would have to have the highest pressure here, next highest, and so on and so on, and in decreasing order. But these ones are actually pass-through pressure regulators. So, well, this one obviously has to be high. Well, actually no. Let me think. Yeah, this one isn't a pass-through one, but these are. So I can lower the first one by lifting this adjustment knob and then just lowering the pressure. And as you can see, this one is now lower than this one. This one is turned way off because I'm not using it at the moment. It's just an extra one. But I want all of them at maximum pressure for this one. So yeah, this one, the panel, I did that on my laser cutting machine or laser engraver. Yeah, sometimes that's very nice and handy to have. Let's see, I'll pause and turn this around. You can see the back side with all that stuff. Just a second. Well, here's the back side of the machine. You have air coming in to this solenoid valve. I think it's called a 5.2 valve. It's a Rexroth 1 or Bosch. So the first one goes up to the air cylinder on top. It's all controlled by the electronics. I'll show you that later. The second air hose coming in, it's used for the for valve number 2 and 3. Valve number 2 controls the bottom air actuator, and the third valve here also controls this one by use of a proximity switch or sensor rather, that limits the travel of the clamp on the release stroke, so it doesn't go all the way down when you lower it. It just lowers a bit, so it's easier to reposition the mold. So that's what that's used for. These, the red hoses, all are exhaust hoses for the cylinders, and these here, the fittings here, are flow control, speed control for the down and upward and downward motion of the air cylinders. You adjust them with a screwdriver. The red hoses go down to a common manifold with a silencer at the bottom. Otherwise it will get really, really noisy when you exhaust straight to atmosphere. But yeah, this cable here is a M8 cable coming from the proximity sensor. This one cable here is the heater element going into the electronic box, and this smaller braid cable is the connector for the type K thermocouple, using proper omega connectors for that. Yeah, I'll turn it around again and show you the electronics. So this is the electronics. Obviously the power cable, the power cord is disconnected from the wall. So yeah, it's a bit cramped, or small. Well, it's not cramped, but it's a small enclosure. So I'll try not to get in the way with my hands. But at the bottom, over here at the back, there's the mains in. These are the 3 cables from the valves or solenoids. Heater element, proximity switch, thermocouple, e-stop over here. The 2 switches for the valves, and then also for the air cylinders, bottom, top. This is the PID, Omron PID Temperature Controller, solid state relay. This one actually isn't the one I'm going to use. This one only has a relay output. It doesn't have a output for driving SSRs. It will work, but the relay in this has limited lifespan or life cycle, number of switching actions it will handle. I think it's 100,000 switching cycles, but a lot more, because this is not it's not switching a huge load, it's just switching this one. But it will die if I put this in PID mode, so well, a lot quicker anyway. So I will switch this to a different model, same model but different type. Yeah, so now I have the PID controller set on off only, not PID, but it works pretty good anyway. So yeah, this is our switches the heating element. Yeah, it switches AC mains, and yeah, here's the input for the thermocouple. It's a panel mount connector, so that one goes to here. And yeah, it's a DIN rail or DIN rail, yeah, with some plinths or terminals. Don't know exactly what you call them in English, that is. So, and also I have to point out that I have no experience with this sort of work. This is the first installation of a in an enclosure like this ever for me. First time I used anything mounted on DIN rails. First time using a PID controller. First time using this sort of pneumatic equipment and stuff like that. So yeah, please excuse anything that I've done that isn't up to standards or whatever. This is not going to be sold or anything. No one else is going to use it except me. So yeah, it works for me. I mean, obviously, by all means, point out any real dangerous mistakes that I might have made. I would obviously appreciate that, but yeah, so far it works, and I haven't been electrocuted, so that's a plus, I guess. I'm using these cable ferrules or end sleeves, or whatever you want to call it, with a proper crimper for them. Proper as in proper, but not proper as in German made. It's a Chinese knockoff, but for this sort of limited work, it seems to do the business. So this side of the 24 volt transformer. This is the main side, and this is appropriately marked 24 volts, 0, 24. S1, S2, the blue one's neutral, brown is live. And unfortunately the Omron controller is a 100 to 240 volt unit. They also have models that run on 24 volts, but yeah, this one was the one I got, so I used that one. Yeah, I'll show you how it all runs, I guess. That's the next step. And all main circuits here in my apartments are protected by a ground fault thing. Or yeah, I can't remember now what the English word for it is, but most of you probably know what I'm talking about. So yeah, let's see this in action. Yep, alright, the mains power is plugged in. Let's turn it on. I removed the protective cover, so it's easier to see the display. So yeah, I always leave it at a lower than ambient setting, so it doesn't automatically turn on the heater as soon as power is applied. Yeah, so this is the Pid controller right here, and yeah, just press like this, and let's put it to 250 and click, and now the heating element is turned on and temperature is rising. The way I have wired these two switches, these are turned 180 in relation to each other for a reason. The lower, well, the logical reasoning, well, my logic is that the lower one is the lower air cylinder, and it is pointing down when it is down. The above switch is the above or the top air cylinder, and it is pointing up when it is up. So yeah, I wanted it that way. I also wired these so that, yeah, they're in series basically, so you cannot actuate the top cylinder if the lower cylinder is in its down position, because you don't want plastic everywhere. And similarly, if you by mistake or forget or whatever, and this one is down, you have just injected plastic into a mold, and this one is up, and you by accident do this, well, no, you do this one first, turn that down, there's still a lot of pressure here, and plastic still left. So if you do that, then plastic everywhere again. And by hooking these up in series, if you release that one first, this one automatically releases. Yeah, going to put the mold into here. So yeah, be right back. So what I've done here is position the mold into the machine, and as you can see, the clamp here is the clamp here is quite a long way from the mold, and I don't know if you can see this, but I just positioned the mold like so into a similar conical shape in the mold, and let's see, and then I press the let's see if I can do this switch, we go. Now it's clamped against the hot end, but it doesn't need to be now, because then the entire mold gets very hot. So when I lower the clamp, it doesn't lower all the way, because the proximity switch catches it and breaks actually this valve right here, which is a check valve with a air pilot. That's air coming from the third valve at the back of the machine. When this proximity switch is activated, air flows here. No, actually the other way around. When it's activated, air stops going here, and this one shuts down and breaks the piston going down, and no air can escape out. So that's very nice, because now you can see the distance here is very small, so it's a lot easier to reposition for each cavity in this or any other mold. If you have another mold, a different size, you just adjust the position of this proximity switch, and yeah, that's it. And temperature is coming up, so I'll put some plastic pellets, these ones. These are, I actually don't know exactly what plastic this is. I got it for basically free from a friend of mine who got it at work, and he didn't really know what it was either. His best guess was, I think, PE or PP plastic. It's a lot easier to use, flows better as well than ABS, which I have tried, yeah, it's semi-transparent, this plastic. So yeah, I'll put some pellets in. It's a bit tricky at the moment. I don't have a small metal funnel yet, but I'll get that. So I'll put the camera down and put some pellets in the top of the hot end. So temperature is coming up, so I have put on my safety goggles. I really don't want hot plastic squirting into my eyes. And this being my kitchen, the trusty oven mitt is doing the protecting of my hand and the soon to be quite warm mold. Unfortunately, I can't show you the result of, or the product when the injection has been made, and I take the plastic part out, because it's a product or a prototype of a product that I hope to bring to market sometime in the future. So yeah, for that reason, and only that reason, I cannot show you, even though I really would like to show you, because it's quite nice. So I put some pellets in here. Now I just hit the switch for the clamp and check that, yeah, it's heated, seated in the injection mold. And now I will hit the top switch here, and you can see the action, and the piston comes down and then stops. And I'll leave it for a while, because yeah, I want to give the plastic time to solidify before removing pressure, and it will cause suction. So that's enough. Pull out and then clamp down. There we go. And let's see. Now I just reposition this to the next cavity like so, and again hit the clamp. This part is something I need to, this part screwdriver pushing some plastic down needs some improvement, and then top switch again, and it presses down and stops when the cavity in the mold is full. Wait a few seconds, and that's it. Yeah, this is hard to do one-handed. This one, yeah, it's not really hot just yet, so put that and clamp that. Now maybe I need some more pellets. It's a fiddly business. So not 100% complete yet, but or finished, whatever you want to call it. But yeah, people want to see it work. I want to see it work. And inject. And that's it, I think. Nothing more to it really. Well, there's some bits to it, such as these adjustment screws right here. Same on the bottom. Well, let's see. Where are those adjustment screws? Maybe there are none. Yeah, this model doesn't have it. Well, this one does. These are dampenings, pneumatic dampenings. Flow valves that stops the piston from doinking into the back or front of the cylinder at the extremes of travel. So yeah, let's turn this one down. Well, actually no, I'll stop recording, fill all the other cavities, and yeah. So there you have it. I have filled all the cavities. I know it has one empty hole, but that one is plugged for one reason or another. So yeah, as you can see, turned the set value on the temp controller to 10, so the heater is off, temperature dropping, and the valves at the back that I showed you before, they are spring loaded, so they have a power off. When the power is off to the coil on the solenoid or valve, it assumes a home position or a position A, let's call it, and when power is applied, it assumes position B. So obviously the position A, which the valves assume when power is turned off to them, should always be the safe mode, or whatever you want. I don't know what you call it, but so this air cylinder actuator in the off position on the valve, pressure is going to this side, putting the piston into the cylinder, and the same for this one. And as you can see, as long as this is powered on and the proximity switch has been tripped, no air is escaping. So yeah, that's not a problem, because when I turn the power off, the valves assume their rest position or safe position, whatever. Position A. And that turns off the pilot air to this check valve, allowing this piston to retract. Yeah, I don't really think I need to point this out, but maybe someone watching this doesn't think that this is the logical way it should be. Yeah, now you know. Power off. All cylinders should assume their safe position. Yeah, that's it. And yeah, I don't know if anyone saw that before, but I'm running the cylinders at just north of 6 bar, which according to these are, what does it say? 90 to 100 psi. Yep, that's it. Thank you again. Let me know if you like to see this sort of stuff. Maybe I'll show some other projects coming up. Yeah, just let me know what you want to see, and maybe I can make that happen. I'm just one guy in an apartment in Sweden doing stuff for fun. Yeah, unemployed, so I have some time to do stuff like this.